Hello everyone, welcome back to Maths within the Sinner. Now, today's topic is LCM and SCF, and we discuss theoretical part, then solve a lot of problems. What's the normally we calculate least common factor and SCF and multiply and find the least common factor and highest common. There, I can deal with in a detail and I explain everything. What's the real life application and everything. Now, let's start the chapters. So first we everyone know LCM is a LCM full form is least common factor and SCF is a highest common factor that we also call GCD, greatest common divisor. Okay. Now first we have SCF discuss. Simply first we everyone know that factorization that is uh, very important for numbers to find their LCM and LCM. What is the factorization? If any number, for example, smaller, we take 6, their factorization is 1, 2, 3. Here is their factorization number. So that we used to for LCM and SCF, and there are a lot of uses. Okay, now discuss SCF now. HCF, highest common factor, also known as greatest common divisor, and the definition is the largest number that can divide two or more numbers exactly without leaving remainders. What's the mean? If any number we find their factorize, there are no remainders. Okay, when there is a equally distributed. We here in a below we discuss the problems and I explain uh, their theory parts is okay. The analogy, think of LCF as the biggest container. If we have bucket of water with different amounts, what is the largest mug size that can measure all them perfectly without leaving drop? For example, I have 12, okay, and their factorization is here 1 2 3 4 1 2 3 4 6 12. That is comes in table of 1 2 3 4 6 12, and 18 also comes with 1 2 3 6 9 and 18. When we divide, there is no remainder. Okay, now we find the highest, that means in both have common. For example, 1 1, here 1, here 1. Now look, another is a greater value in both numbers. Yes, 2. There is another. Yes, 3. 4, 4 is missing. And another 6, 6. And 12, there is no 12. So highest common factor is 6, that is available in both the tables 12 and 18. So what is the highest common factor? Yeah, is a S6. We can easily find with factorization method. Okay, that is so easy. 12 and 18. Okay, that is the easiest method we for easy calculation we used. For example, we must take a table when that comes in both the numbers, and that is the highest number. When we two table we take 2 6 are 12, 2 18. Okay, that is also come with 2, and 2 6 are 12 and 2 9 are 18. Okay, now another take 3 2 are 6 and 3 3 are 9, and 2 and 3 is a different number. So here is the SCF is 2 into 3 is equal to 6. That's the easiest way to find the SCF. And here is the explanation for in detailed. So how do we find the SCF? I hope you understand SCF. Now we discuss LCM. LCM is the full form of least common multiple, yeah, least common multiplication. Okay, the smallest number that is a multiple of two or more numbers. In other words, the first number multiplication table means. Okay, now I discuss everything. Think of LCM as the first meeting point. We Okay, now here is the example. If two cars start at the same time but travel at different speed, when is the first time they will side by side? Again, here is the uh, 4 and 5. What is the in LCM we multiply 4 into 5 is at 20. Okay, now we can read the table until that comes same numbers. For example, 4 ones are 4, 4 twos are 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 six are 16. Again 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20. Here is we look that here comes 20, here 20. So is the what's the LCM of 4 and 5? 20. So we can easily find the LCM in a table method for basic understanding. Now we have to trick shortcut. Okay, now first we take uh, factorization 4 and 5. You can take different like 4 4 and then 5. I can take in a both numbers in us directly. First we read 4 ones are 4 and 5 never comes in first table. Now read 5 table, 1 ones are 1, 5 ones are 1. Now that multiply both numbers 4 into 5 is equal to 20. Here is the shortest way to find the LCM. Now I give another example. For example, we took greater values. For example, 20 and 30. Okay, now we smallest prime always take a smallest prime factorization number for tabling, but I took directly a greater number to. Okay, that's a not a good way, but okay, now took a smallest numbers that take a more step, but okay, that's okay. 2 10, then 15, then 2 5 10, and 2 15 never comes. Okay, 5 no, 3 3 fives never come, and 3 fives are 15. Okay, now 5 ones are 5. So what's the their numbers multiplication? 2 into 2 into 3 into 5. So 5 into 3 15, 15 into 2 30, and 30 into 2 16. So what's the LCM is 60. Now I hope understand how to find the numbers LCM and SCM crystal clear. Now we discuss a lot of more examples, and the theory portion is very important. Different types of LCM and SCF uses. Okay, now read first. Why do we study them? The purpose SCF, LCM, and arithmetic, but to algorithm thinking regarding efficient synchronizing LCM to understand cyclic events. It helps us calculate when different repeating events. I will discuss in the with example in backside in below side. Now first in a theoretical part we discussed was what is the uh, types of for example okay, now I give a hint. For example, uh, a bell rang 2 minutes, then after 5 minutes, then 18 minutes interval. That's help to find the next time when the bell is rang. That is a we use synchronization LCM, optimization LCF. To understand maximum efficient, it helps us figure how to split resource equally. For example, I have something like I have 15. Okay, I and three friends are there. I want to split in a everyone to equal. So here is a first person, second person, third person. We distribute in 5 5 5. So optimization method, and then fraction operation. Yeah, fraction. We cannot add or subtract fraction with different denominators without finding a common ground. For example, 1 and minus 2 by 3. So we first went to their denominator to equal. So how to denominator? Here is a denominator is 1 and here 3. So what we do? We multiply numerator and denominator 3. Then we should calculate 3 upon 3 minus 2 by 3, and denominator is same, so we take 1 denominator 3 and 3 minus 2, then 1 upon 3. This type we can solve the problems. uh, okay, now use in daily life, that is very important. Why we discuss and why we learn to LCM and HCF, why that is important in our daily life. So now we discuss real life uses of SCF splitting. Tilling of floor, you have a rectangular room. Okay, I have a rectangular room that is a 12 into 16 meter. Okay, okay, size is like, okay, assume that. Okay, that a difference 12 and 16. Okay, you have a rectangular roof 12 meter into 16 meter and when to cover it square tiles. Now we cover two squares, square like a square size. Okay, and what is the largest size of tile you can use that no tile need to be cut? Okay, so what's the square size we have to use and there is no cut? Okay, so here is the length and breadth. Now we take SCF and then we easily find the 12 into 16. 2 6 12 and 2 8 18, again 2 3 3 and 2 4 8, and there is a different number, so we can't take again the table, so 2 into 2 is equal to 4. So what is the largest size of tile you can use? 4. What is the size is 4 meter to 4 meter square size we can use, 4 meter square size use. Okay, now distributing sweets. You have 20 chocolates, okay, 20 chocolates and 30 candies, 30 candies. You went to make identical gifts back for students, no leftover. What is the maximum number of bags it can make? Okay, for we take 10 and 15, then 5 uh, to 10 3, and again there is a different reminders. So here is the SCF value, 5 into 2 is equal to 10, so we can distribute maximum 10 for each student. Okay, uh now carpentry, cutting two ropes of different length into piece of equal size, yeah, that's also example. And real life uses of LCM. Now we discuss LCM real life examples. Traffic lights, one light change every 60 second. Okay, every 60 second change, another every 90 second. What will they change together? Now what they will change together? Now we again factorize the matter. I took a greater values for to step to remove a few steps. Okay, directly I took 10. 10 60 is a 6 time and 10 9 is a 9. Then 3, 3 2 is 6 and 3 3 is 9, and 2 and 3, 2 1 is 1, 3 1 is 1, and 3 1 is 3. So when we multiply all this number, what we get? 10 3 3 9 9 18 and 180. So what's the value is? Traffic light, one light changes every 60 seconds, another 90 seconds. What will they change together? 180, total 180. Okay. Racing runner complete a lap in 4 minutes, runner B in 5 minutes. If they start together, when they will meet again at the start line? Again we take 4 into 5, there is directly different number, 4 1 7 and 5 5 1 7. After 20 minutes they will meet together again. Okay. uh, medicine 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 schedules, you take a pill every 4 hours and a syrup every 6 hours. When will have take both the same time? Okay, now okay, I take a pill in 4 hours and syrup 6 hours. What will have to pay same time? So now find the same times. Again we same process will we follow, 2 2 3, and that is 2 and 3 also factor of 6, so 6 is at 12. So that is easy. If you command it, then you can solve directly. But in an exam, you can detail factorize all these numbers. Problem tables in exam focus. Okay, now exam oriented questions are there. When teaching problem solving, help student identically keywords to identify SCM and SCF problems. Yeah. When we start a SCF problem questions, that numbers are mostly in exam. That is the keyword: largest, maximum, greatest, longest, equal distribution, cutting speed. That types of number are given that you can understand. That is, we find the SCF: largest, maximum, greatest, longest, equal distribution, cutting speed. For example, 15 boys and 20 girls are divided into teams. Each team must have the same composition. What is the greatest number team possible? Again, I took a greater values for directly. I know that 15 and 20 is a multiple of 5 table, 5 threes and 20 and 5 fours are 20. So here is the SAV is a 5. So what's the answer is 5. And 3 and 4 is never come with the uh, same table. The measurement problem, finding a common question. What is the longest step that can measure the 1.5 meter and 2 meter exactly? Method convert into, okay, like 1.5 meter. I know that 1 meter is equal to 100 centimeter. So we can convert in a same. So 15, 1 point decimal, then after we denominator is 10, meter is equal to 100 centimeter. 1 0 cancel, that we here 150. So here is the 150, and 2 meter is equal to 2 into 100 centimeter is equal to 200 centimeter. And find the SCF. Now we find the SCF directly. I can use the 150 into 200. I also know that there is 0 0 that also come in 10 table, 10's table, and 15 and 20 also comes 5 table. Directly I took 50 tables. 50 into 3 150, and 50 and 400, uh, 53 150 and 50. Okay, 54 times 200. Okay, now there is a different number, so there is no uh, common factor. So here is the 50 is a SCF. Okay. SCF remainder problem, that is very important in common, especially in competitive exam and Olympiad and other competitive exam. You definitely look the same example. Okay, find the largest number which divides 29 and 60, leaving remainder 5 and 4. What was the remainder first? 4. 29 and 4, what we get? 25. Okay, and second 60 leaves 4 respectively. So again we subtract 4. 60 minus 4, 56. Hmm, there is any common? No. So what's the common? That comes 20, 25 and 56. Any of the table? Both numbers are no. So there is a SCF is 1. So what's the SCF is 1. If I make sure that I'm sure there that never comes with any. If you look any error, then definitely comment in the box. Okay, now move to LCM. When we solve LCM problems, always that keywords are look that always you take LCM: smallest, minimum, least, together, simultaneous, meeting point, repetition. That numbers, that words keywords are if you look in a question that you understand, that is a LCM problem. Okay, now the Bell Lights problem, event repeating at different intervals. three bells ring at interval 10 and 15 and 20 minutes. Okay, three bells are 10, 15 and 20. They continuously ring after interval 10, 15 and 20. When time they meet together. Okay, now we find the LCM. So first we took a smaller table value for two fives. 10 and 50 never comes to stable and tens. Okay, now directly I take 5 ones are 5, 5 threes are 15, 5 2 and 2 3 and 2 comes with 6 table. Okay, so when we multiply 6 5 30 into 60 after 8 a.m. 60 minutes is equal to 1 hour. Okay, so 8 hour plus 1 hour, what is the time? 9:00 a.m. Next bell, all three bells are ring in same time, 9 a.m. Okay, so here's the answer is 9 a.m. The smallest number problem question: find the smallest number which is exactly divisible by 12, 15, 18. Okay, now again took a factorization method to deal with this, to find the solution. Find the smallest number which is exactly divisible by 12, 15, 18. Okay, now take a table. mm, 3 tables. 3 fours are 12, 3 fives are 15, 3 6 are 18. You can always take a long method and prime factorization order. First we do 2 3 5 7 and order. I am experienced and I have the knowledge about how to I can clearly show the numbers when appeared, and then I directly took a greater values for time, uh, for time saving. Okay, 3 fours are 12, 3 fives are 15, 3 6 are 18, and directly. Okay, 2 twos are 4, 5 6 3. Then 5 into 5 into 3 15, 15 into 2 30. 5 into 3 15, 15 into 2 30. Okay, now multiply. 3 into 3 9, 3 into 6 180. What is the LCM value is 180. Direct method, and now we can, how to, that is a correct value when we calculate, how to find that is a correct. So we can divide 12 divide by 180. 12 ones are 1 and 6, 12 fives are 15. Yeah, that is divisible by 12. Now we also take, and then 15, 15 ones are 15 and 3, 20 times, 12 times, that is also divisible by 15. Now also take 18, divisible by 18 ones are 1 and 10. So you can easily can find that is a, verified that is a correct solution or not. The remainder problems in question: find the smallest number which when divided by x y z leaves the same remainder, same in each case, LCM x y z. Okay, we first, any numbers are given x y z, then we take a LCM and add on remainder. Okay, r is represent to remainder. Here is a dollar is a error when I copied and paste. So now discuss LCM remainder problem. Here is the formula. Okay, now I already discussed. Now we took example for explaining. Find the smallest number which when divide 6 at 12 leaves remainder 3 in each cases. Okay, first we take a 6 at 12. LCM was LCM is, 2 3s are 4. Okay, then 3 ones are 4 and 2, and that comes both in 4 stable. 4 into 3 12, 12 into 24, plus what's the in case remainder is 3, we just add on, and here's the 27. When we divide that number, always when we divide by 6, that always how to verify that is a correct solution. When we divide this 6 8 12, 6 8 12, that always get a remainder 3. Okay, now table 6 4 is a 24 and 27 subtract 3, 8 is a 24 subtract 3, 12 into 2 24, 24 and 27 minus 3. So there is a correct solution. So you can find and verify that how to solve these problems. Okay, and there is a most common in any of the government exams and competitive exams that comes most of the time. For checking answer, it only applies. Important formula for checking works: product of two numbers, HCF and LCM. That product is if a b is a any number and they are HCF, a and b. Here we can note down. Okay, a b two different numbers, and their HCF and LCM is also equal to. Okay, for example, number 6 into, here is the example, 6 into 4 8. What is the number when multiply 48? Now find their HCF. 6 and 8, HCF is 2 3 and 2 4, and there is no common, so HCF is 2. Now find LCM. 2 3 6 2 4 8, and 3 ones are 3, 4 ones are 4, then 4 ones are 4. 4 into 3, 4 into 3 12, 12 into 4 24, 48. So you can easily find LCM SF. What's the in examiner asking when like they ask their SCF is 2 given and LCM is 24 given and one number is missing, like a6 is given and b is missing, then what's the second number? So we can just multiply 6 4 and b is equal to 8. So here is the different type. One number is missing, like missing SCF is missing, LCF is missing, then we can easily find the numbers LCM SCF. I hope I explain you detailed, and you can understand very well, maybe, I hope. And if you have any doubt, please comment in the below, and like, and also answer 121 1331, their LCM, what is the LCM and SCF. Okay, comment in the below, and I hope understand everything and I explain a crystal clear everything. And if you have any doubt, please comment in the below, please support, and I want really your help. uh like, share and subscribe, must I need your what's the problem, please subscribe. Really, thank you so much, I enjoyed a lot. And what you, if you have need any of the topic you want on next video, please comment in the below, I definitely make a videos. Thank you and bye bye.